important for exam. Okay, we have already discussed about electrolytic cell. We also have discussed about electrolysis. Then we have discussed examples of electrolysis, though I have not done more, but I have discussed 2 examples, I think. One, though, along with electrolysis, I have done it. The electrolysis of sodium chloride. Okay, I like to tell you that if you do the electrolysis of sodium chloride in molten state, it will give us sodium, metal, and chlorine gas. And if you do the electrolysis of aqueous solution of sodium chloride, in that case, you will not get sodium metal, you will get hydrogen at the cathode and the chlorine at the anode. Then I have told you that electrode can be of 2 types. Passive electrode. So passive electrode is the one which only conducts electricity and doesn't take part in the cell reaction. And active electrodes, they do participate in the cell reaction. So we have taken one example. In case of the active electrodes, we find generally we use platinum and we use graphite also. But in 1 or 2 cases, you find that graphite reacts, but graphite does not take part in this directly in the electrolytic reaction, but it takes part in the byproduct of the reaction. That we have lost the scope of discussion because this unit is not now being included in your present syllabus, which is the isolation of metals. Then we have found that if you do the electrolysis of copper sulfate using platinum electrode, in that case we find that copper is deposited on the surface of the platinum, and in another platinum electrode we find the evolution of oxygen takes place. But when you take and gradually you will find the blue color of the solution fades. This is this might come in the exam, that while carrying out the electrolysis of copper sulfate using platinum electrode, why does the blue color fade? So we will say that the blue color of the copper sulfate solution is because of the cupric ion. As gradually the cupric ion get reduced to copper, so the concentration of the copper in the solution decreases and the color fades. And if it continued for a long time, it will be colorless. All the copper ion is being removed. And now if you do the electrolysis of the copper sulfate using copper electrode, in that case we find the copper ion of the copper sulfate goes to cathode, and the impure copper from the anode goes into solution. So in that case we find the sulfate has no role in the reaction. So every moment from anode, 1 copper goes into solution by loss of 2 electrons. These 2 electrons travel to cathode and reduces copper ion to copper. So throughout the process, the concentration of the copper ion remains the same. So there is no change in color. Okay, now we'll go for Faraday's law of electrolysis. Faraday's law. Law of electrolysis. See, I think I may not be wrong. Faraday was working as a laboratory attendant along with Marconi. Okay. By helping Marconi in all this setting up of the experiment, he also learned a lot, and he has done wonderful work on the electrolysis. Faraday's law of electrolysis. There are two laws are there. Okay. So it's called Faraday's first law of electrolysis. Yes, two laws. Huh? So what is very simple law? It says the amount of substance liberated. Why do I say liberated? Because we find sometimes some gases comes out like oxygen, hydrogen, so they don't get deposited. The amount of substance liberated or deposited, if it is a metal, at the electrode is, I should not say, because generally deposit takes place at the cathode only. Okay, I'll write at the electrode is directly proportional to the quantity of electricity passed through the electrolyte. Please write down the law. I'll write here substances of electrolytes. Okay. All right, yes. Let W gram of substance liberated or deposited at the electrode by Q amount of electricity. Or you can say Q amount of electrical charge. Okay, or you can write here, or Q amount of electrical charge. Right, thus, what you can write here, W is proportional to Q. We know Q is equal to what? Q equal to
Current into time.
Current into time. So therefore I can write here Q is equal to, we'll write here ampere. Okay. No, sorry. You I sometimes I forget. I into T. So where I is equal to current in amperes and time in seconds. Please remember, these are different between chemical kinetics and the electrolysis. In chemical kinetics, time may be second, minute, or hours. In this case, it should be always in seconds. Right. So therefore, what we can write? Oh, sorry. Wait. I made a mistake here. Please excuse me. Or I will write here, or W is equal to Z Q. And where Z is a constant of is constant. So now we'll write now that we know Q is equal to I into T, where I is equal to current in ampere and T is equal to time in seconds. So this is equal to question 1. Therefore, W is equal to Z into I into T. If I is equal to 1 ampere and T is equal to 1 second, so therefore W equal to Z into I into 1 into 1. Therefore, W into I. There is a probability constant and is known as electrochemical equivalent. Right up to this, then we'll write the definition of electrochemical equivalent.
Done, sir.
So now we'll write definition of electrochemical equivalent. So now you know what is electrochemical equivalent. It is the amount of substance deposited at the electrode when a current of 1 ampere passes through an electrolytic solution for 1 second. We'll write here definition of electrochemical equivalent. It is the amount of substance deposited at the electrode when a current of 1 ampere is passed through an electrolytic solution for 1 second. Okay. Now, how to calculate Z then? See, Z is equal to chemical equivalent mass divided by 96,500 coulomb. Okay. Now, what is chemical equivalent mass? That I have already discussed with you in class 11. But anyway, I don't want to trouble. Chemical equivalent mass is also known as CE is equal to atomic mass of the element divided by its charge. Okay. So if I put a symbol, these symbols are not given in the book, and you also should not follow. Okay. So if atomic mass of the element, if I write here M, and if charge is equal to N, it may be plus or minus. Okay. So in that case, what I can write? Z is equal to M divided by N into 96,500. Okay, so this I put, let me put is equation number 2. Okay, right up to this. Okay, I'll just change it here. So what I can write therefore? Therefore I can write W is equal to M into I into T divided by N into 96,500. So this I have done for your mathematical calculation. Then why you are keeping quiet?
Just now, sir, finished.
Okay. Let us do a small sum. I think those who have already done it, you might have done this one. Calculate the amount of copper deposited when 5 ampere current of electricity is passed through copper sulfate solution for an hour. Okay. So we will write now here answer. We know W is equal to Z into I into T. So the moment you write, you get half mark. Okay. Then we'll write here where I is equal to 5 ampere. T always you have to express in second. So it is 60 into 60 minutes into 60. So 3600 second. Then Z. I have to calculate Z. So Z is equal to what? Atomic mass of copper 9 into 96,500. See, Here I will write down here. Atomic mass of copper is 63.5 gram mole inverse. So I'll write now here 63.5. See, in copper sulfate, when it ionizes, you get Cu2 plus and SO4 2 minus. So what is the charge on copper? 2 and 96,500. All right. Just for writing this, you will get half mark, and for doing calculation for this, you will get half mark. Now, please find out. You have calculator, and please do it.
-29 into 10 to the power minus 4.
3.29 into 10 to the power minus 4. Okay. So now you put the value here. Put all the values. Write down. So how much it comes? Z is 29 into 10 to the power minus 4. Then it is pi. Then it is 3600. Find out gram. How much it comes?
$5.9 grams.
5.9 grams. All right. Okay. Then you will be given a simple sum of 1 marks. Only 1 mark. Calculate the amount of electrical charge required to reduce 1 mole of Al3 plus to aluminum. It's very easy. Right. Written. See the answer. Answer is very easy. See here. You have taken aluminum. To this aluminum, if I add 3 electrons, then I get aluminum. Each aluminum ion takes 3 electrons. So how much it is given here? 1 mole. Then you require here 3 moles to get 1. See, the amount of electrical charge carried by 1 mole of electron. See, 1 mole of electron means Avogadro's number. What is the charge it carries? 1.66 into 10 to the minus 19 coulomb. Okay, you will find it is approximately, actually, is not 96,500. It is less than that. But just for calculation sake, we consider it to be 96,500. 96,500 coulomb is a very large number. So because of that, we make it small. We call it 1 Faraday. Okay, that is we write here 1F. So how many moles you require? 3 moles. That is 3 into this much or 3 Faraday. Therefore, what is the answer? Answer is 3 into 96,500 coulomb or 3 Faraday of electrical charge. They are very simple. So this type of sums will be now given from your redox reaction also. Anyway, it will be given also. See here. In the following redox reaction, how much of electrical charges involved? So don't get scared. Huh? See here. Al Cr2 O3, it is 2Cr plus Al2 C3. It is very easy. See here. What is the oxidation state of this? Cr2 O3 is nothing but 2Cr3 plus and 3 O2 minus. So chromium gets electron from where? Aluminum only. So to reduce chromium into 2 chromium, we require 6 electron. Then only you will get 2 Cr. So how much is the answer? 6 Farad. So we'll write this one. So we'll write now here 2 Cr 3 plus 6 electron is 2 Cr. So here it is what? 2 moles and it is 6 moles. So 6 moles will carry how much charge? Write down. It will be 6 into 96,500 or 6 Faraday. how much of electrical charge is involved in the following redox reaction? See, so we'll do it. We'll find out how much electron transfer is there. So right now here, MnO4 minus Mn2 plus. See, what is the oxidation state? +7. +7 has come down to what? This. And oxygen will be converted into water. So I'll write now here 8H plus into 4H2. All right. Who has given this electron? Ferrous. So it is Fe2 plus give you Fe3 plus +1 electron. So how much mole of electron is required now? Yeah, 5. I need not balance it. So the in this redox reaction, 5 moles of electrical charge is involved per mole of MnO4 minus. Therefore, it requires 5 farad.
Done, sir.
Faraday's second law of electrolysis. Okay. So first I'll explain, then only you'll write. Initially in the first law, we have taken only one electrolytic cell. In this case, we may take a series of electrolytic cells. Okay. And where you'll find all the electrolytic cells are being connected in series. Series. Okay. Say this is copper sulfate. This is zinc sulfate. This is silver nitrate. Okay. Then we have put all platinum electrodes here. So right hand side is cathode, left hand side is anode. This, and they are being connected. Okay, and this is being connected to an emitter, and it has come. Okay. Okay. What will happen now? This copper will go and deposit there. Zinc will go and deposit here, and silver will go and deposit on the cathode. So if you compare the weight of copper deposited with the weight of zinc, you will find they are proportional to their chemical equivalent. Okay, I'll write down. When same amount of electricity is passed through different electrolytes, connected in series, then the amount of substance liberated at cathode is directly proportional to their chemical equivalent. So I can write here briefly here. Say I go for left. So I'll write now here. Say it is W zinc by, I take a ratio, W copper, by W zinc. Okay, is will equal to what? Chemical equivalent of copper by chemical equivalent of zinc. Okay, then suppose I compare this and this, then what will happen here now? W zinc by W silver is equal to chemical equivalent of zinc divided by chemical equivalent of silver. Or what I suppose if I compare this and this, then I will get here W Ag by W copper is equal to chemical equivalent of Ag by chemical equivalent of copper. If you wish, you can just make it reversals.
Yes, sir.
Done.
Yes, sir.
Okay, then we'll do one sum. Please wait, let me find out.
Done, sir.
Do it. I will not do. What do we have here? AuCl3. What do we have here? Copper sulfate. So now you know that you want to find out the copper, na? So I'll write copper on the top. WCU by W gold by chemical equivalent of copper, chemical equivalent of gold. Okay. Now here I have to give here atomic mass. Atomic mass of gold is 197. I think so. Yeah, 197.0 gram mole inverse, and copper is 63.5 gram mole inverse. So you know how to calculate what is chemical equivalent. I taught you. It is atomic mass divided by charge. So what is the charge of gold here? AuCl3. What is the charge of gold? How much charge gold is having?
+3.
Yes. So you have to divide it by 3. And for copper sulfate, you have to divide it by 2. So put the value, amount of gold is already given. Find out. Put those values. Weight of copper is how much? this much. Very easy sum. Statement is very big. Because of that, it makes someone nervous.
We got 20.37 grams.
How much did you get?
20.37 grams.
Is it so? I think it is 4.76 gram.
Wait, I think I made a mistake. 65.67 divided by 51.75. Huh? Oh, sorry, mistake, sir. Point 76. 76.
Then, now see, calculate the amount of current pass. You can take the help of anyone. Suppose you take copper. We know W is equal to what? Z into I into T. So here I you have to calculate. For copper it is how much? 4.76 gram. T is equal to 5 hours. It is 5 into 60 into 60. And what is Z copper? We know 63.5 divided by 2, 96,500. So now find the value of I. Or if you can take gold also, no problem. Gold is already given. W is equal to this much. T is same. Z will be equal to what? 197 by 3 divided by 96,500. You can put any value and get value of I here.
$8.63.
8.63. Do the calculation again. See.
Okay, sir.
Wait,
sir.
Look at the decimal.
Oh, into 10 to the power minus 11.
No?
10 to the power minus 11.
M is 0.804. On San, doing all ulta sum.
4.76. Right. 4.76. Copper. Copper is 63.5 divided by 3 to 96,500. 3.5 divided by 3 divided by 96,500. 2.19. So 4.76 by 2.19 into 10 to the power minus 4. 5 into 60 into 60. 1800. 4.19 times 18. I got a completely different answer now.
What about the other? Others are not doing or what?
Ah, God. is equal to Z into I into T. I is equal to W by Z T. W is equal to 4.76 and Z is equal to 63.5 by 3 into 96,500 into 1800. Two to 18. How much was the answer again, sir?
You tell me.
0.80. Wait, I'll put that through the calculator. 4.96 into 2 into 96,500 divided by 63.5 and 560. 0.80, sir.
Then why you are writing all? Then in exam you'll do such mistakes. Gone. Okay, enough for today. Next day we'll do electrochemical cell.